like it's live. Microphone. Forget it sometimes. Testing. Yes. Science voice. Here we'll just do some. It's not working. How come it's not working? Oh, I have my speakers off. Testing. Huh. Okay. Science voice. So it's working. Anyway. I don't know. I haven't quite finished my polarization red-black thing. So yeah, I really probably should include the neutrons because they're part of this. It is, like I said, in hindsight, it's all going to be like, oh shit, that's so obvious. Oh shit, that's so obvious. But getting to the place where you can do the hindsight thing, it's a little tricky because there's so many moving parts, right? I mean, I'm talking about the speed of a photon has to be spread over a million other elements. And it literally has to be spread over a million little elements. I mean, there has to be an internal mechanism that actually swirls the mixture perfectly. You know, not like a big beater that mixes the whole bowl, because that wouldn't make things move right. So it's like it's got to be a lot of little beaters that somehow the mechanism inside of matter is such that each little atom is doing its little thing, and each electron, each proton, each neutron, they're all just mixing the mixture. I did think of a diagram for a neutron that I thought was kind of interesting. So I'll see if I can draw a quick little picture of it. Let's see, it would look something. I have to draw it like in its real, in this real world kind of. Man, I'm getting old, manny, kind of jittery, but I always have been like that. Well, it just comes out like a cowboy hat, actually, so that's kind of simple. But this would be your proton, three-dimensional object, and the neutron would be a loop that fits around it. And that sort of makes sense because now the neutron can stabilize protons so they can be closer to each other and still maintain, also probably still be able to prevent electrons from crashing into protons. So it can do both duties. You know, it'll be creating a field, essentially a repulsive field, and repulsive to electrons, and that could work, I think. So, but anyway, I mean, it could account for why protons are closer to each other than they should be allowed to be, and essentially neutrons are what makes that possible. And they call that the strong force, but I don't know. You know, they don't blame the neutrons, but the neutrons always kind of have to be there for the strong force to be there. So I think the neutrons are providing the strong force. So anyway, but that's a side subject. I mean, it's a subject I haven't fully explored. It's just a thought. You're trying to make neutrons into something. They're obviously critically important because they use neutrons to initiate volatile chain reactions that create things like nuclear bombs. I mean, so it seems this neutral thing does have a key role to play. And but it does also seem like it's not really traditional roundy thing. And I don't think by making it a dipole, you know, a magnet, you know, with actually both elements, that you could make it so it could keep protons closer than they want to be. So I think it has to be something that actually is attractive to protons in this part and repulsive to them on this part. And yeah, that gets a little tricky. But anyway, but you can understand that if it's could be a two-dimensional object and still be very useful in terms of smashing nucleuses. And clearly it'd be pretty easy to hit a nucleus with a neutron if you give it some kind of polarization, because there's a lot of charge in nucleuses. Lots of protons. So if you make it if you make it partially attractive to protons, that is in the center, and then repulsive on the outside, you can create a configuration where the neutron will move right into the nucleus and collide with it, which I think is necessary to create chain reactions. You're not going to be very likely to crash. I mean, that was why Einstein basically said, the odds of creating a nuclear bomb, a sustained nuclear reaction, were, and he made up some kind of shooting birds in your pajamas on the 4th of July at 4 o'clock in the morning, or whatever he said. So he gave some little analogy for something very, very unlikely. And then, a few months later, a guy did it. And so, Einstein looked pretty stupid there. But the point is that it was hard to imagine how a neutral thing could hit nucleuses. And obviously they do. So that's, I think, kind of important. That they somehow must be attracted to nucleuses to do that. And so anyway, side subject. Didn't think I was going to do that, but I did it. So so I did. So comments. We'll do some comments, I guess, and see how that goes. Comments on the message board, the website one, or just, that guy's starting to piss me off. But I'll get to that. All right. So Ye Pray Guy one said, well, anyway, in an abstract way, you are explaining gravity and particle science with concepts out of everyday experience. Yeah, well, I don't know if that's really how I would describe it. I mean, people keep using this intuition word, and, they keep trying to malign, what I would consider just realm of reasonable explanations. So I would argue that when they when they did analysis of, say, the two-slit experiment and started talking about photons splitting in half and sending out radar and doing complex probability math, that was unreasonable. And when you have the problem of this convergence for gravity, where this stuff moves into each other, I just don't think it was reasonable, to say, let's bend something that doesn't exist and make the stuff fall down the hill. I mean, it's reasonable in that, okay, that'll do it, but it's not reasonable in the sense that, how are you going to make that infrastructure out of something called physics? I mean, out of physical things. That doesn't sound like physics. That sounds like magic. And you can go on, but so I don't know if I like the idea that I'm turning it into something common. I'm turning it into something reasonable. While modern day physics is doing the exact opposite and telling us everyday experience is an emerging property from fundamental quantum physics and relativity. Yeah, well, relativity is a real problem too. This whole idea, I mean, again, it was never logical to just say stuff just moves. So that always bothered me, because the just move part, I'm saying, like, how would you find the just move part? Again, I can make the analogy, but if I have the falling apple and I have the not falling apple, how are the two apples different? To me, there's got to be something in the apple that's moving that's different than the apple that's not moving, because it keeps doing it. It doesn't just do it and then stop. It doesn't run out of this fuel. It just keeps going, and the keep going just seems to imply something more than just it has a thing called momentum. And momentum has to be, in my opinion, always thought to me, it has to be made out of something. There's a something that makes momentum, not a nothing. Again, it's this nothing explanations. Nothing is not a good explanation. it just does is not a good, that's not very good physics, which are basically mathematical descriptions without any anecdotal explanation to support it. Well, again, I don't have anything wrong with mathematical explanation, so that I don't think that's the problem. I don't think the interpretation, whether it's crazy, fuck, silly nonsense, I mean, whatever, Copenhagen, many worlds, pie in the sky, whatever. I don't. It's not that they're mathematical; they're just made up, and they're made up in what is, they're real abstract, and they're they're gingerbread. You know, they're fairy tale kind of stories with special superpowers. They're making up the story of Superman or something. They're not making up a rational story. So anyway, so the Maurice guy, thanks for taking the time to explain in more detail. It makes much more sense now. And yes, my jargon is not precise. Very little knowledge on the subject. Take time to be more precise next time. Keep the great work. Okay, thank you. All right, so Cat of the Wiser or something. I don't know. Cato the Wiser. Cato the Wiser. Okay. According to Gary's hypothesis, there's a thing such as absolute motion, perhaps? Question mark. Well, according to my hypothesis, quite obviously, I've said the explicit words that motion is absolute, that you have an absolute velocity based on all the motions that have affected your matter. Every piece that goes into you, if a little particle comes into me from space and hits me and goes inside my skin, I've absorbed that force. And that force is going to propel me in a sense. I'm going to be impacted by it. So every atom, every molecule, every bit of me got to this location, this collection from a trajectory, and all of that adds up to something. And that's my absolute motion at this exact moment. Now, in another moment, I'm going to be in a different field. And so there's going to be new stuff hitting me from new angles because I'm in a gravitational field. And that field is in another field and another field that are all impacting each other at the speed of light. And anything could change at any moment. A sun could blow up in our own galaxy. And the force from that could be coming towards me. And today could be the day it shows up, that kind of thing. So my motion will be dictated moment to moment. My absolute velocity will have a different vector from moment to moment and a different speed and amplitude. But the fact that I have one is a fact. So yes, I'm saying that quite explicitly. All right. I get the impression that dogma says all motion is relative, but that never sat well with me if light travels at a constant speed. Yeah, well, there's reasons. I mean, I don't really know why the constant speed would make the acquisition of force obligatory, that you can't just get rid of it. You have to get rid of it. If you don't get rid of the force, you have it still. So that argument is the argument I'm making. If you're in isolated space and I hit you with marbles from different directions, that force stays in you until something else hits you to take it away. And that's a fact. And yeah, you don't need a constant speed to understand that you absorb your acceleration. And in absorbing acceleration, that creates velocity, and the velocity exists and will stay until something changes. But what you actually did was absorb force. That's what acceleration is. It's the absorption of momentum. Seems like Gary's view would jive with that better, or maybe there's no conflict to begin with. I'm not well versed in this field. Yeah, well, I don't know if there's a conflict with the speed of light. There's a conflict with the idea that matter isn't substantially different than atoms or protons, or more importantly, quanta. We're not quanta. We're not fish. We're a school of fish. Schools of fish can't do the same things fish can do. And certainly one of the things a school can't do is go the speed of light and still be called a school, because then all the fish are going the same way, and it's a mob of fish. It's not a what you'd call a school. It's a blob of fish coming right for me. Anyway, Okay, yeah. It's another comment by the same guy. I had a physics teacher in high school that said he could make a case that there was no such thing as pull, only push. Naturally, as kids, we didn't want to accept it. His example was that if you tied a rope onto something to pull it, that it was the rope on the back side of things that was attached to that was pushing it. So that's something like my hook example. My big hook would do the same thing. You're being pushed from behind. It made me think he might have a point. The problem with the rope thing is, again, you're doing this pulling part of the rope to create the push from behind. And that's still a non-starter as a force idea of pulling. How do you know? Pull is still doesn't have any meaning. In the sense that you can think of the rope as a rigid thing, and then you could think you're just moving the push to behind the thing and then pushing. I mean, it's easier if you make it rigid, but the mechanism, the motion of pull is still weird. That the pull here would, I just mean it still needs a lot of infrastructure to make that happen, where push just requires me to have motion and to bang into something. All right. Pushing it made me think he might have a point. If gravity was due to some unequal pressure, no, the gravity itself is just due to the fact that there is pressure and you are in association with something else and creating shadow. So in that sense, yes, the pressure becomes uneven once you cast a shadow. So once you absorb acceleration towards something, so once you just nudge towards something, you've absorbed the force. And as stated in the last video, the important one, the one that should have gotten a little more respect because it really was a good video. The slowness, now the force has gone from being a speed of light thing to a very slow moving thing. So the imbalance is in the sense that the timing of the force's arrival is now perhaps many thousands or even a million times slower, and that's the imbalance. The force still is on its way, so to speak, but it's going the long way, doing the matter school thing. It's swirling in a school of fish instead of going. All right. So the question was, all right, if gravity was due to some unequal pressure, then wouldn't the shape of the object matter? It's obviously the density matters in the sense that there's more gravity coming from the Earth, so to speak, to the sun from the diameter. So the longest distance, the thickest part, is creating more absence of gravity than the thin bits, in the sense that there's more to accelerate. So the more parts that have to be accelerated, the more fish that have to be processed, that is essentially requires more force. So it takes more force to poke the middle section out than it would take to poke the end section out, if you want to look at it that way. So in that sense, shape matters, but in the end, it doesn't matter because you're talking about objects that are far enough away from each other that shape is sort of irrelevant because the field is dampened into a point field, a center of gravity field. It will look from the observer getting affected as if the force is coming from a point particle. All right. A flat object would be drawn to an object like the Earth at varying rates depending on orientation. Well, again, it's not the shape of the object doesn't matter. It's the amount of atoms, and the atoms all move at the same rate. So again, we're back to the nuclear argument. So there's two arguments here. I mean, there's two elements to the force. There's the force the sun is casting, and then there's the force the Earth is casting. So you got to be careful how you state this question. So the acceleration from the sun is a consistent obligation to move forward, and it doesn't matter. Density just doesn't make any difference. Mass doesn't make any difference. It's every little bit is going to feel the force and be accelerated by the force. And that's the function of matter anyway. As I'm pointing out, the very function of matter is to take the one photon goes in and it spreads it over my entire mass and moves my total mass because they're all connected and they're all connected and they're all connected. So in a sense, you can't separate from that. So the real truth is it's not even just the atoms, it's the electrons and the protons that are being affected by the gravity, and the neutrons. So they're the ones that are being moved. They're the ones being accelerated. And the point is that the quanta in them are the ones neutralizing the force into a single vector of movement at a much slower rate than the force rate. They're combining all the influences of acceleration into one vector of motion. If gravity was due to some equal pressure, even the flat object, blah, 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 blah. Now, I think we know that not to be the case. Right. And it still isn't the case. Again, you have to, I have stated, gravity is a nuclear force. Gravity is affecting the littlest bits. It's not affecting anything by mass. So you always have to think of it in terms of shape being sort of irrelevant, but it's certainly not irrelevant to what your contribution to the gravity will be dependent on your density. So you can't block force. You can't cast the shadow unless you have the mass to cast the shadow. So the effect you're having on the sun in terms of causing it to accelerate, that force is dependent on your mass. All right, if gravity is due to some unequal pressure. Okay, if gravity is a push based on unequal pressures, wouldn't the orientation of the object matter? Again, the gravity that makes you move is based on the shadow being cast on you. And so it's it's the little bits. Again, I can't say that any clearer, but frankly, shape might matter if you're big enough. I mean, if you're so dense, the matter is so dense, it might. I don't think it's possible. So no, I won't say it. I was going to say that it might be able to use up all of the force, but in a sense it can't, because it's not using it anyway. It's just changing polarization, and it'll do that through any depth, to any depth. So it's just changing polarization, causing things to take those right turns, and it'll do that to every single quanta in the material. All of it will be affected, and so it just doesn't matter. Shape doesn't matter. If gravity is a pressure, it would act like a sail. So yeah, no, there's no sails. It's all, again, the only bits that are really moving are the quanta. The rest of it's an illusion. So I guess that's the better thing to say, is you can only affect fish with the force. And yes, only fish in matter, okay, are going to be affected, but that's the rule. But that's the trick of it. But it's only the fish in the school. You're not affecting the school. You're affecting the individual quanta in the school. All right. That's stated well enough. And such. Let's see. I better go check to see if I got any comments. Some right windows. Anyway, no comments. Okay. Good enough. Bastards. Anyway, so I guess I'll just do the message board tripey guy and try not to be too insulting, but these people get a little bit irritating, like they're running the show or something, or like I'm obligated to give them personal instruction, or every question they come out is somehow just so interesting, and I should waste my time. You know, um, I let them set the agenda, and I just don't. I don't go for that kind of crap. I mean, there's a point where it's just nitpicky bullshit, and he's just pulling crap out of his ass. So anyway, all right. If you say force pushes, not pull, where is the source of gravity if it is a constant push force? Thanks. Well, I've already done the source, so yeah, okay, that might have been one of the old comments. You still not explained, not a very good sentence. How can a bit of energy that travels with the speed of light from a universe full of bits does not lose speed or energy? Well, why would I have to explain it? It's the rule. I mean, light works that way right now. No physicist says light slows down. So why don't you harp on them? Why don't you go say Feynman was a shitty physicist, or he didn't answer the question, or gee, they haven't explained. You really think that needs to be explained, asshole? It's just what it does. I've told you the simplest. I'll give you this simple diagram, right? You got this simple thing. It only has one feature, polarization, and it can be at a frequency. But it only has one feature. It moves the speed of light. All of them are the same mass. They move the speed of light, and they have a polarization. I've cut it as thin as you need it to cut. Can't get any simpler than that. God damn it. And you're fucking asking douchebag questions like, well, how does it keep going? That's just the way it is. That's the rule, okay? I'm giving you the foundation. This is what it's made out of. There's not going to be a why to that question. Ever. There's not going to be an answer to that question, in my opinion, ever. It's a fundamental feature of a material universe. Let's see. Travels with the speed of the collision between two bits does impulse theory work? What? The collision between two bits, does impulse theory work? I don't know what that means. P equals mv, sum of all the impulses equals 0. Law of energy conservation. Well, yes, conservation is, there's no loss of conservation. Where have I argued that you can hit something this way and that you don't have to hit it this way to get to 0? Of course you do. Anything absorbed from the field, so if I absorb energy and a velocity in a direction, it means the field somewhere. If I'm going this way, somewhere in the field, there's force going that way. So, yeah, I mean, I've already been over that crap. So, fuck you. You're really being obnoxious. Okay, I got it. Now, I don't think you got shit. According to your theory, there is no static bits. But where does bits moving the speed of light come from? Well, again, that's like asking why is there something and not nothing? Why is there a universe? How the fuck do you expect somebody to answer that question? And where's the example of physics answering? Where is the conventional physics answer that question, jackass? It's not relevant to what I'm doing. I'm disputing their silly wave theory. I'm disputing relativity. I'm disputing bent space. And I'm disputing their idiotic notion that time is in a dimension somewhere when time is a function, not a dimension. That's what I'm doing, shithead. Where is the source? So again, fuck you. God, the unicorn, I don't care. Who causes the bits to move with the speed of light? Who causes it? I guess it was God. God who sat around forever and ever 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 and ever. And nobody ever asked, what made God? Cunt. Jesus, who causes the bits to move with the speed of light? He who always was, but will not accept ever being asked how he got here. Yes, that guy did it. Anyway, so then his last comment. Well, how light reflection works in a mirror? Great question. Well, a great sentence structure. Well, how light reflection, it's some way to start a sentence, works in a mirror. It depends on what kind of reflection you're talking about. The angular reflections versus straight on reflections. But I'm not messing with much of that. We already know some of that theory in the sense that the photons go into the electrons and they get refracted inside either the atom or the electrons, and they bounce around. And they're probably just doing this 90-degree angle thing. So I think any idiot could sort of understand that if I move something to 90-degree angles, it'll end up coming right back where it left. But it's probably a lot more complicated than that, in the sense that the light goes in, the photons as a quanta. They probably take lots of right turns, and then there's some point, okay, where they hit a electron in the right mood, in the sense that it has an extra quanta, or it has some other imbalance that causes it to be the field energy compels it to be released in the equal opposite direction. So in absorbing the energy of the impact, it has to release the equal and opposite reaction, which is the photon. What force redirects these bits to 90-degree angle? Well, you got that. It's a 180-degree angle in total, obviously. So obviously, one 90-degree angle won't get you a reflection. That'll get you a refraction. But anyway, yeah, there's a mechanism in the atoms, and I haven't gotten to that yet. But clearly, that's not physics that I'm necessarily disputing any kind of conventional notions of, because the conventional notions are pretty much that, yes, that's what electrons do. Energy goes in and energy comes out, and sometimes it comes out perpendicularly, and sometimes it comes out in the direction it came in. So, yeah, so fuck you, though. I mean, fuck you in this how did the universe become a universe kind of shit. Fuck that. All right, so I did my job there. So, is there anything left to do? Perhaps not. Mostly. So yeah, I really am working just on the procession part, and it's how something moves. The tangential dimensions have to get moved forward, and as I just kind of implied, what's that sound? I don't know whether it's something electrical going funny, or whether it's some kind of bug going funny. Huh. Not my magnets. Yeah, interesting. Might be my speakers. Yeah, some sort of noise in the computer. Interesting. There's a face. I wonder if it's an evil face. Does it have a name? Josh. Well, that doesn't sound too scary. Let's see. I made God. No, that doesn't sound too good. All right, so I don't know if Josh is going to be worth anything. What you up to, Josh? Just being a troll or what? Yeah, it's funny. You can't click on their name and do a damn thing. So, yeah, I don't need people doing the poser thing. So, poser is not welcome. You got to say something. And you're not doing that. Not typing anything. Some problem with your technology, Josh? We just... See, I hit this thing. I hit the mute. That doesn't do anything. Oh, there's an asshole. Oh, don't know what that... Gee, that was just so interesting. Yeah. I mean, this whole muting. I mean, wow, I don't know what I'm going to do. What a crisis. Well, anyway, it's good it's public because then you'll not be, you'll just wait till I'm famous. You're going to feel so bad, so embarrassed that this video's still up and everybody's going to see what a little turd you are. So anyway, good night, Josh. It just looks like you just can't handle the technology. So I'll say goodbye. So I really don't need your face in my room. I just don't do this social thing. And the comment I made, God, is just kind of useless. So I mean, that's just turd behavior. I wonder what that frickin' noise in my speaker is. Some problem with the computer, no doubt. Could poke around. Let me see if I pull these cables out, what'll happen. Yeah, it's kind of an annoying buzz. Turn it down. Anyway, not your problem, sorry. Yeah, both. This Windows 10 thing I really hate, but this computer is weird. I mean, it's a fairly new computer and it's very low profile. You know, it's like a laptop in a desktop box, but a small one. So at least it's energy efficient. But anyway, it's got like 14 sound drivers. I'm just like, what is that? These realistic. I don't know why it needs 7 drivers to make sound. But anyway, so I was thinking I might just try to find a low-profile sound card just to avoid that. That just doesn't sound right. I mean, it doesn't seem right that you need 7 drivers to make sound. And the sound sucks in some respects. I mean, the quality isn't bad. I mean, but now that little buzzing sound's going to bug me. Let's see. Your theory lacks substance. No, that comment lacks substance. So you don't understand the word substance. I have articulated it in depth, lots of drawings, lots of analogies, lots of substance, asshole. I work for an engineering firm. That doesn't mean anything. And we do photonic circuitry. What exactly is a photonic circuit, retard? Light travels in a straight line, newsflash, from point A to point B. There's no such thing as a photonic circuit. What we do disproves you every day. Well, you're just full of shit. We account for superposition and action at a distance for quantum logic boards. You're just full of shit. You're a liar. I mean, you're just demonstrating you're a liar. There's no such thing as a photonic circuit. The only kind of circuit is an electric circuit. You have to move a charge through conductors. Now, you can certainly use a little bit of light here and there to create an effect. So if you want to transfer a current from one thing to another thing and isolate it from ground, well, a great way to isolate it from ground is to convert it into light and then shoot it into a photoresistor, and then you can isolate it from ground. But that would, the causes for using light are to block it or to in some way use the light to do some sensing. But you would never use the light to actually make a circuit. You can't make a light capacitor. You can't make a lot of things you can't do with light. doesn't do like resistor. It could probably do. I don't lie. Yes, you do. A little link. Well, I'm just saying, if you've got the goods, douchebag. Yes, my technology was fucking up on me, asshole. Well, again, you're the one who posted the idiotic comment and then can't do the technology thing right. So you're going to make a comment that's stupid, and then you're going to come into a room and not say anything, and then you're going to blame me for calling you an asshole? You can fuck off! Jeez, douchebag. No, I'm not going to look up photonic circuit. It's a stupid word, okay? And it doesn't disprove anything I've said at all. You'll never prove that you have action at a distance and spooky action. You'll never prove it exists, ever, because it doesn't. Entanglement is nonsense. It's not a theory I need to argue because I don't have to account for any experimental evidence in that field. You don't have any experimental evidence that is in any way anything but made out of technical interpretations. No, I used equations. It doesn't matter. Equations can be full of shit. The equations that create black holes are garbage equations. They make up a force stronger than the one that exists in gravity. They can make matter compressed. Where's the evidence that you can compress the Earth into the size of a grapefruit? That you could take all the electrons and all the protons and all the atoms inside the Earth and compress them into the size of a grapefruit? Where's the evidence that there's any force in the universe that would allow you to do that? So your equations don't mean anything, asshole. The proof is in the fact that your company, whatever you're working for, clearly doesn't do anything of any use to anybody. It's probably just some silly university that wastes money. The center of the Milky Way is kind of irrelevant. If you think about galaxies, it's kind of obvious they're not solar systems. Galaxies have an even distribution of matter on one side as the other side. Very different than solar systems. So theoretically, galaxies don't even need anything in the middle because they're spirals, and those spirals are the gravitational centers. So the little suns are all moving towards the center of the spirals, and the spirals have a gravity pulling them towards each other, and the oppositeness is also pulling them in, and that's creating the centrifugal force. So the pulling of their tails is what's causing them to spiral. But it has the model is completely different than the sun-centric model of a solar system. A solar system and a galaxy work nothing like each other. The mechanics is completely different. You don't need any kind of speed at all to find comfort in a galaxy. You're not going to shoot to the center of the galaxy. If I put a dead charge, so to speak, a test charge in a galaxy, a test Earth, it won't go flying into the center. If I gave it no velocity and I just put it right there in between two spiral arms, it's going to move towards one of the spiral arms. It's not going to move towards the center. So they don't even, physicists have done a lot of stupid things, but not to realize that galaxies aren't solar systems is really stupid. All right, it has to be incredibly strong. No, it doesn't. What about dwarf and ellipticals? Well, again, those are not common in the first place, and they're obviously ones that have been affected by interactions. So, yeah, ellipses aren't a big, huge surprise. You can sort of understand that a big, giant thing is creating galaxies through all this condensing of gases. You could sort of understand that some places are going to have a lot of things created, some places are going to have very few things created. I mean, there's galaxies that even have galaxies spiraling out of the galaxy, so there's they're so big, they're creating little galaxies, that are flying off of the arm of the galaxy. They don't have intricate spiral arms. Well, they don't have them yet, right? Think about it. Wouldn't it take a little time? So if I create a field line for magnetic filings, let's say, and I throw some filings on, well, at first you're not going to see anything. It's not until I get a good enough density, not too much, but enough, before you really see, before all the stuff starts piling up on the field lines. So the same rules apply in the formation of a galaxy, is that it's not going to have a perfect spiral arm at birth. No, those have to be built up over time. So that's why the really massive, the biggest spiral galaxies have really quite magnificent spiral arms. So I would argue that the older ones have the best arms. What about ancient elliptical galaxies? Well, you don't really know. Just because something's far away doesn't mean it's ancient. Well, I mean, in the sense that obviously if you can see it and it's 15 billion light years, you're seeing the light from it. It doesn't mean the thing itself was ancient. It could have died the next day. It could have been 15 weeks old when you saw the light from it. So we could be seeing light when it's 12 years old. We're not seeing light from today. We're seeing light from when it was 12 years old, and maybe it died when it was 22. So you got to be careful about understanding what time the light taking so long to get here means. Is you're just seeing a picture of what things look like 15 billion light years ago. You're not seeing a picture that's at all relevant to today, and you're certainly not able to say the thing is still there. Well, that, of course, would be idiotic to say. The thing, of course, isn't still there. 15 billion years have gone by. It's nowhere near where you're seeing it. It's long gone. Let's see. They don't have an intricate spiral. What about ancient? Okay, yeah, I already did that. So, yeah, I'm caught up. So anyway. Reasonable questions, some of those, so thank you. Not terrible. And such. Yeah, let's see, pop back up. I guess I can get rid of that. So anyway. Yeah, I don't know if there's so much about what they, there's two kinds of physics. Obviously, there's the macro, micro kind of thing. You can do the telescope thing or the microscope thing. And, I think the more relevant one to my subject matter is the microscope thing. But, yeah, I'm surprised, just by some of the things that you watch physicists talk about it, and I'm just surprised how many times they say something and you're just like, he really doesn't realize that a galaxy isn't a solar system. I'm really surprised. Don't you argue for your Tesla coils? What does that have to do with me? I'm not Miles Mathis, retard. Jesus Christ, you're stupid. What about free energy? Well, now you're just being an asshole. There's lots of free energy in the sense there's lots of quanta that represents motion or force, and it's locked in polarization in matter. So I mean, obviously we already know that this pen could be used if you took all the energy in it, all the polarization locked in it, and you released it, you could fly the Earth to Mars really easy. So it's kind of free in a sense. You got to admit, wow, that's a lot of energy for it just cost a pen. But the trick is releasing it without blowing your hands off. Look, I'm not here to play a social game with you. Okay, so you don't want to take interest in the channel. You don't want to watch any of the other videos. There's hundreds of them. I'm really not here to satisfy your curiosity and to answer your questions. I want to answer physics questions. So, and apparently you don't want to pay attention to what my theory is and what I'm defending. So go talk to Miles Mathis, not to me. I mean, if you don't understand how rude it is for you to think I'm somehow obligated to let's just stop everything and get him up to speed on what you've been doing for the last 4 years. I've got 4 years worth of videos on this, at least 3 years worth of videos on this channel. And you expect me to just sit there and take the time to explain the whole story to you again, even though I've done it in 15 different videos. Male crack horde. Oh, I'm rude. You're right. You show up here and play games, and I'm the rude one. Yeah, well, you can fuck off and die. Soon, hopefully. I was watching a video on magnum effect and that reminded me of the possible analogy of how spin could cause fish to move through the field. And well, spin is a tricky concept. So, I mean, obviously, yes, there's the 90-degree turn thing, but realistically, these really are just positions, and all that's really changing is the polarization. So, I mean, I know this, you're not going to believe this part, but what's really happening is there's a suit of clothes, and a different fish pops into it every single millisecond, going a different direction. And it's just about where the suit of clothes go. It really doesn't matter where the fish are always going in straight lines. So when the suit of clothes moves this way, it's because a fish going this way wore it for a little bit. And then when the suit goes this way, it's because a fish that kept going this way wore it for just a couple of seconds. And then it went this way. It's a fish going that way wore it for a couple of seconds. So it's always, there is no such thing as the actual fish wearing the clothes going around in a circle. There's just the illusion of a bunch of vectors that do that. The vectors that wear the suit are doing that. So the force, the fish that are being allowed to wear the suit, okay, as funny as that sounds, but that's how it's happening, because the fish have the right polarization coming in. They're being allowed to change polarization and wear the special material suit. But there's another, their privilege is brief, and then some other fish earns the privilege, and then another fish earns the privilege. So it's like numbers in a deli or something. You know, each one gets their turn, and yeah, that's probably the better way to say it. Each one gets their turn. Yeah. Remind me of the possibility that a spin could cause fish to move through the field. Yeah, okay. So yeah, so what you're saying isn't terrible. I just want to. It's really hard to say this the right way, right? Because the particle word is broken, the momentum word is broken, lots of words are broken, and you know, even the idea of orbit is on the quantum level. It's a different kind of mechanism. It's exchanging, not pushing. So the push doesn't really exist. The push is an exchange. So nothing gets pushed. And as I sort of argued for that. And we're just using the word push gravity to describe the idea that the acceleration comes from outside the thing towards the inside. So it's an outside force moving things. So it's always the outside force that's doing the moving. There's no such thing as an internal force that does the moving. All right, gotta be careful how I say that now. You have to take away a force to create motion. It's a shadow. Well, anyway, the point is, it's not really pushing. What you're really doing is absorbing. So, I mean, absorbing is a lot different than actually talking about something being pushed by being hit, and then that's it. You're just hit. Well, no, it's like my hand goes into you, and then nothing comes back out. You know, it's like I don't leave my hand in there, but the force stays in you. You know, I don't know how to, you know. I'm just saying that's why the words, how I say it, has to be a little careful. So when somebody says spin, I got to be really careful, because spin is is thought of as a rotation thing, and rotations are thought of as momentum things, and it's really not an issue of momentum. It's not an issue of pressure, still an issue in the sense of but it's the pressure of the probability of certain vectors of interaction with certain polarization. So the polarization, the suits, who's wearing what suits is really all this is about. It's not even who's wearing them. It's what direction is the suit moving. So what fish is the suit on at this particular moment? And that's all this is about. And what decides what suit gets worn is what suits are in the field of suits. Oh, god damn, I have to come up with an analogy that's better than suits. But I have to give the suits a property, you know, where somehow having a blue suit here and a red suit here means something. That somehow that pairing of suits is important. Yeah, well, that's a pattern, and I could say patterns are important, and that might be a way to create some kind of shortcut of understanding. But the irony is the actual arrows never turn, technically. The polarization turns. The suit turns. And I know that just probably doesn't mean anything to people because they haven't been thinking about this as much as me. So when I say the polarization is a suit, it's this, the shape. And this shape is fundamentally important. This is the difference between a negative charge and a positive charge, is this shape. And it's critically important. And so all that gets exchanged is the shape is going this way, and then there's an interaction, and the shape is going this way. And then there's an interaction, the shape goes this way. That's what's happening, is this orientation is the thing turning and moving. Could you make a computer program simulation that could? Yes, of course I could, but I need time to do that. So I need to be like matter or something. I need to go into time suspension mode where I can take like 10 years to learn how to do that. Yeah, I mean, I've messed with HTML5 actually for browsers. It does have these flash kind of features, where you can do the little bouncing ball thing. But like I said, I just don't. I want to get this moving. I want to get this published. I want to get this going. Spending a year making an animation, I just don't know if that's a productive use of my time, because it's going to take me some time to learn how to do that. But I have looked into it, obviously, enough to know that it's there, and maybe I can exploit it. But, maybe that's something I can hire done or something. But, I really don't have money. So I'll have to get a volunteer to do it. And, I don't know. It's kind of high-end work for volunteers. I mean, you're going to have some familiarity with 3D image manipulation software. And of course, all the math that'll have to go with that. I mean, not that it'll be that complicated, but once you have first you have to program the potential movements of the balls, and then you have to do the math of when those potentials are realized. So the realizing potential isn't that difficult, but the actual limitations of what the ball can do, speed of light, simulation, and proportional speed, and polarization. That'll be the hard thing to do, especially in 3 dimensions. As a 2-dimensional model might actually be quite useless. Quite incomplete anyway. I don't know about useless, but incomplete. I have a plethora of resources for learning computer stuff, more than I can even look through. If you want some, a plethora, I guess that is, of resources for learning computer stuff. Well, I think the internet is a plethora of resources, so I have one of those too. I have an internet. Could any amazing technology be developed from an understanding of physics the way you understand them? Frankly, yeah, I mean, I would argue that getting it right is going to matter, but they might be negative. You know, I mean, theoretically, I mean, I've always kind of thought this was possible, but I think it even more now, that you could actually find the neutron that unravels the inner universe, you know, that just that causes a chain reaction that effectively is like a virus, and it just destroys all the electrons. You know, they just keep wiping each other out, and it just, you know, just spread like a wave through the universe and just annihilate all the matter. So yeah, I mean, that's not exactly a selling point, right? As the brilliant technology, that it would be amazing technology, but I guess it wouldn't be kind of the stuff you could sell. But yeah, I guess I would argue that understanding, once you understand this whole right turn thing and magnetism, I think it's going to be really important in terms of you could gain efficiencies out of things like photovoltaic cells, maybe. I haven't even got into the super cool, you know, superconductor kind of stuff, but you know, they certainly have done so many physical experiments with that stuff that they've probably already sucked out all you can suck out of them. But I mean, you know, theoretically, a more coherent laser. I mean, I think a laser that doesn't diverge should be possible. You know, that doesn't have any divergence in it. So I think that should be. It would be possible. Like, you first have to create like a magnet to create the lasing. So first you have to create like not only crystals are already geometric, but what you need to do is like put them in a huge magnetic field or something to line them up even more perfectly, so that every electron fires at exactly the same angle. Something like that. No lenses required, and that all the photons produced would be parallel. So all of the polarization would be absolutely parallel, and all the suits would move exactly parallel, kind of a thing. So yeah, I'm just saying that there's lots to be. This whole idea that it's only polarized field energy that's relevant to matter, that affects matter in any noticeable way, is, you know, is huge in terms of a difference in terms of understanding. Even the understanding that velocity is a collection of force, and that the force exists inside of the matter, and that the matter actually is more energetic, more unstable because of the velocity. That's got to be also useful, I think. No doubt. But you know, I haven't really had time to start doing that kind of thinking about development possibilities, which might be a fruitful thing to do, because you know, maybe there's something in it for me. You know, in the sense I could invent something valuable. But it's really not my agenda right now, really. But I mean, it could serve both purposes. Yeah, reward me for my efforts, and make the theory relevant to other people by essentially proving it because I came up with a technology based on it. Creating an aimed photon might be a good thing to do, work on. What you really have to do is take away apertures and lenses and create almost like a LED. An LED, the light's created by a little blob of silicone. Emits the radiation, and it's almost like you need to um, enhance that kind of a platform and just no lens, no bullshit, and just have um, just make the LED so that the light isn't diverging. So either make the light emitted only from one layer of electrons, or it'd be a much dimmer light, but it would be much more coherent or colonnaded. I mean, technically, photons don't diverge much. When you think about light coming from 15 billion years ago, it doesn't spread much. In a sense, it's almost converging when it gets here. It's like the light from the top of a galaxy and the light from a bottom of a galaxy that could be a light year across or something. That light comes into a lens that's maybe 10 inches across, and both of those photons are still coherent to each other. So it seems like it should be possible to create a really good laser. I would think. Can't get any smoke out of my vaporizer here. Need my nicotine. So let's see if there's anything else I wish to babble about. Yeah, I'm just doing a lot of drawing, and that's a lot of patterns to try to just get that. I mean, I think I got the polarization part correct. Which thing is creating which thing and how they're exchanging it. But it's the why the absorption of the velocity, the absorption of the acceleration. It just has an interesting feature that I am having a hard time drawing it. But the idea is, I'll just give you the idea of it. So the sun would be giving off in a gravitational circumstance. Well, maybe the sun's not a good example because it is doing the the proton electron thing. It's creating both positive and negative polarization field energy. And that's less effective, than the external force energy. So I'm going to have to explain why. But between like a proton and an electron, the real trick is the electron, let's say, is producing a polarization, and let's say that's the road that the wheel of, so the proton essentially is creating the road that the wheel of the electron can roll on. So for the electron to move, it needs for the right color suits to come in, the road suits. So now it's going to get wheels and road. Now I'm really going to get into trouble. but that's essentially what creates the procession. So what I'm basically saying is that the wheel exists, but it needs a road to roll on, to process, to move the wheel forward. And that's the trick of it. So to really have acceleration towards something, the something has to produce field energy that you can roll on, in a sense that you have that the balance of the equal, one going this, your stuff is going this way, the stuff coming at you is going this way, and it creates that pair idea. And that gives you the, like the tank tread, and it just is a tank tread that can't roll until it has the bottom tread has to be coming at it. So something has to feed you the bottom of your tread, so to speak. Like there's no bottom to the wheel. All you have is the top of the wheel, and you need the road to provide the bottom of the wheel, in a sense. Something like that. To get procession, for the thing to process, to spiral through in a forward direction. But yeah, I don't want to get that, yeah, it's going to be complicated to draw, but anyway, that's what I'm working on. So I wasn't ready yet. I wanted to do it, but just not there yet. So anyway, but I really wanted just to argue all the other generalities of bent space and relativity and the two-slit experiment and all the other shit I have talked about with people who wish to defend conventional interpretation, which I think I have demonstrated to be quite unreasonable compared to this wonderful kinetic simplicity. And such. So anyway, I guess we got no showers and not too many viewers, and so I guess we'll just move on and try again some other time. So till the next time and such, so forth and whatnot.